This is the notes video for pages 3 and 4 of Unit 2, Part 1 review. So this is going to be 15 through 19. I apologize, I already did the answer key and the video did not record the picture, so this is the answer key I'll be going through with you. So feel free to pause at any moment if you need to, if I'm going a little quickly and you need to write your work down. So number 15 says a rectangular garden has a length that is 6 feet more than twice its width. So I went ahead and I wrote down the width is equal to W and the length is equal to 2W plus 6. So the rectangular garden has a length that is 6 feet more than twice its width. So that is us clearly defining our variables. It says it takes 120 feet of fencing to completely enclose the garden's area. So although they use this word area, remember when we talk about fencing, we're talking actually about the perimeter that we're going to be placing this fence, the perimeter where we add up all the sides. So it asks us to write an equation that could be used to find the width of the garden. So I went ahead and I set up my perimeter equation. I did 120 was my perimeter, and that's equal to width plus length plus length. Width plus width plus length plus length. You can condense this if you'd like, but it does not say to do that or solve it. It just says to write an equation that could be used to solve it. So I stopped right there. Part number 2 says explain how your equation models this information. So I said, since the width is W, and the length is 6 more than twice the width, it must be 2W plus 6. We then add up all of the sides. And I did a little parenthesis here again, the sides 2 widths plus 2 lengths to equal 120 feet of fencing. Again, explain means to write in a sentence form. Please feel free to pause this video if you need to write the answer down, if I'm going too quickly. Part C, find the length of the garden algebraically. Show how you arrived at your answer. So this is us going back up here, and I'm going to go ahead and as I write it, I simplified it. So I just went and said I had 1 plus 1 is 2, plus another 2 is 4, plus another 2 is 6. So I said 6W, and then 6 plus 6 is 12. So just condense this equation as I rewrote it here. I solved for W, I subtracted the 12, I got 108. I divided by 6, and I got 18 for my width. Be careful, that's not what they asked you for. They said find the length. So we have to take that width of 18, go back up here, and put it right in for W. So 2 times 18 plus 6, 2 times 18 plus 6 got us 42 feet. Number 16 says solve the following equation for V in terms of all other variables involved. So here we have V, and we want to get it by itself. So we have to move the 2, we have to move the K, we have to move the minus H. R is already on the other side. So we want to undo our PEMDAS. Now we're not going to distribute the 2. Remember, we're trying to get the V by itself. We're not about putting something right next to it. So I chose to undo this whole big division bar of K. So I multiplied by K because that's how you undo division. You multiply, and what you do to one side, you do to the other. And that got me over here with 2 parentheses V minus H equals R times K. Then again, I'm not distributing. I'm trying to get the V by itself. So I'm going to divide away the 2. And then that leaves me with V minus H equals RK over 2. And then finally I add over the H. And remember, remember, it's just going to be this large answer with all the other variables on the other side. Number 7 says 2 correct first steps are shown for the same equation. Which property justifies each? This kind of goes through what we were just talking about, where you may choose to do the distributive property, or you may choose to undo and divide that number away to solve. So that this would be an example of the distributive property, and where we go ahead and divide away. Here's the tricky part. We don't use the division. We don't have a division property or say it's division property. It's actually the multiplication property of equality, okay, because we're really multiplying by that reciprocal. It's technically, we have a 1 over 5 over here, and we're canceling it out. That's the same thing as having a division of 5. So that's the multiplication property, and because we're doing something on one side and the same thing to the other, we add the of equality on the end. Number 8 here, remember, we are going through and looking at our properties, writing those down, writing each step down. So it says, give a property of real numbers associative, commutative, or distributive, or a property of equality, either the addition or multiplication. So remember, notice they've only given us those two. So if we do see subtraction, we say the addition property. And if we do see division, we say the multiplication property. Okay? So number 1, I see that they had parentheses, it's no longer there, and they did do the distributive property. Number 2, I looked to see what changed. It looks like these two just swapped places or changed order. CO for change orders are commutative property. Number 3, looking at what changed. Again, be careful here. It looks like they took the X and moved it out. So that is just kind of undoing our distributive property. So that is, even though it's undoing it, we still say it's the distributive property that has been done. And then they went ahead and added those numbers together. That was not a second step. So now how did it change from this to this? Again, looking at the differences, it looks like they subtracted a 15 on each side. So that's going to be, remember, it's not a subtraction property of equality, it's our addition property of equality. And then that would cancel, we'd get the 7, so then they just reduce. So then from here to here, what did they do? It looks like, again, we subtracted the 4x and subtracted another 4x on each side. So that would be the addition property of equality once more. So then those would cancel there. And then looking from this step to this step, they, it looks similar to number 3 up here, where they pulled the X out. That is the distributive property. Okay? And then from there, they just simplified. And now this is the tricky one right here. So typically we would just take this equation and divide away the 3 to get our answer. But again, we don't have a division property. So notice what they did. They multiplied by the reciprocal, okay? And what we do to one side, we do to the other side. So with that particular question, it's the same thing as dividing by 3, okay? It's just, it looks a little bit differently. So we're multiplying by the third on each side, so that is our multiplication property of equality. Again, pause the video if you need time to write these answers down. Number 19 here says 2 consecutive even integers have the following property. When the smaller integer is added to 3 times the larger integer, the result is 2 less than 5 times the smaller. So it says Raphael tries to model the scenario, but unfortunately he made an error on the left side. Explain what error he made. So the first thing we need to do is figure out what the error is. So 2 consecutive even integers. So if we remember when we were talking about consecutive integers, that means consecutive means one right after the other, and we have 2 of them. So here I used x. Let me just change it to n since the Raphael uses n. So we use n as the first variable, the unknown, and because I don't know what the next number is, I have to just use n again, and that's going to go to n plus 2 because I want to skip over that n plus 1 because that's going to be odd. So again, if we're starting off with an even number, it goes even, odd, even, and so forth. That's how the number system goes. So, and because I said only 2 of them, I'm only doing n and n plus 2. If I needed to go further, I would do n plus 4, n plus 6, and on and on. So what happened here, it says that the smaller integer, n, he got that right, is added to, he got the plus sign right, 3 times the larger integer. Well, the larger integer is not just n, and this looks like it's just 3 times n, and then an addition of 2. He needed to do 3 times the entire larger integer. So that's what we want to write down here. Raphael forgot to include parentheses around the expression n plus 2. In his equation, only the n is being multiplied by 3. Where he really needs to have the entire n plus 2 multiplied by 3. Again, pause, make sure you have all the words down. Lastly, here it says write the correct equation if you haven't already and solved it to find the 2 consecutive even integers. So we do need to solve for both. So I went ahead, I copied that down, I had the parenthesis there. We are going to go ahead and distribute combine like terms. So distribute, that's how we get the plus 6. That's what was wrong up here. We're going to go ahead and add 1 and 3 to get 4. I went ahead and subtracted that 4n over 5 minus 4 is 1n. Brought everything down, and then I added 2 to the side to get 8. Now remember, I don't just want 1, I want both. 2 consecutive even integers. Make sure the numbers are even, that you did do those right. Make sure they're integer numbers, which they are, and the answer, again, if the first number is 8 and the next number is 8 plus 2, it has to be 10. So 8 and 10 are our final answers.